Hi everyone, this is Mr. Zikri. In this episode, we are going to study about gas pressure. Gas pressure is divided into two categories. First, the air pressure or atmospheric pressure. Second one, pressure of enclosed gases. There are several questions that we are going to answer. First, what is the air pressure? And how does it affect us? Now, the definition of air pressure, actually the weight of the air above us that makes the air pressure. So here we have a picture of Earth, and here is a column of air. So this 1 meter times 1 meter column of air, it will have one atmospheric pressure at the surface. How much air is there in this column? Well, actually air has mass also. So here I have a thought experiment. For example, you are provided with two balloons, and then those two balloons is hang on a rope like that. If you blow one of them, for example number 1, what will happen to the beam here? Is it going to turn to the left or to the right? Yeah, exactly. This beam will be turning to the left because on the left side the balloon is being blown. This proves that air has mass and it has weight, so it will make this balloon going down. So this mass of the air above us actually 1 ton or 1,000 kilogram. The question is, why do we not feel it? Why do we not feel it? Why do we not feel the air pressure to our body? Is there any answer for that? Okay, I'm going to remind you again. 80% of our body is consisted of water. That's right. So this water will have its own pressure and it is going out from our body. So because of that, the air pressure that is going to our body is being opposed by the pressure of the water inside of our body. That's why we don't feel any pressure. So here some trivial fact that you have to memorize. The air pressure at the sea level is 1 atmosphere equal to 100,000 Pascal or 100,000 Newton per meter squared, or equally with 76 centimeter hygrogyrum or 76 centimeter of mercury. Note, the atmosphere extends up to 120 kilometers above the Earth's surface. Above that, there is no air pressure. It's almost vacuum. Next. So here is several layers of our atmosphere. So here is troposphere, where the cloud and rain and thunder is produced or happen, and above that is for the plane to fly. Above that there is ozone layer that is protecting us from ultraviolet. Above that there is stratosphere. Next there is mesosphere. Next there is ionosphere, that is reflecting back the signal radio from the earth to the earth. And there is thermosphere. After thermosphere there is exosphere. So here troposphere enables water vapor rising from the surface of the earth to be condensed and turned back as rain. Second one is stratosphere. The third one is ozone layer, prevents harmful radiation and ultraviolet light coming from space. And there is mesosphere, that is protecting us from meteor by using friction to burn meteor at this layer. There is thermosphere, ionosphere, reflect radio waves broadcast from Earth back down to different part of the world. And the last one is exosphere. So here is the uses of atmosphere, their duty to ourselves. So they protect us from UV, cold of the space, meteors, and harmful radiation from the sun by actually deploying Van Allen belts. Next, let's read this part. The air inside the balloon exerts pressure that keeps the balloon inflated against atmospheric pressure. Similarly, fluid inside your body exerts pressure that works against atmospheric pressure. So this is actually the answer for the first question I gave you on this video. Next. So to measure the air pressure, we use this apparatus. Actually, it is very simple. This one is reaction tube filled with mercury, and then this one is petri dish, and you close this reaction tube with petri dish after you fill it with mercury, and then turn it down like this. Now we use, what is it called? It is called barometer to measure the air pressure. As you know, this is actually liquid. So this liquid at this point having liquid pressure P, and as you know, it stops to going down because there is air pressure. That this air pressure is balancing the pressure of this mercury. So the height of this mercury indicates that the pressure at this point is actually equal to 1 atmosphere, or the depth of mercury 76 centimeter. If you want to find out how much air pressure is that, let's do liquid pressure of the mercury. Density times G times H equal to 13,600 kilogram per meter cubic times 9.8 Newton per kilogram times 0.76. It's actually 101,292.8 Pascal, or we can round it up as 10 to the power of 5 Pascal. And here is the example of how the air pressure decreases if we goes up. Here at the sea level, the air pressure is 101 kilopascal, but when the height is increased about 400 meters above the sea, the air pressure becomes half of it and then goes above it. The air pressure is about a third, and here 12,000 meters, the air pressure is 20 kilopascal or 1/5. And in 150 kilometer above the sea level, the air pressure drops to 0. The air pressure decreases by 1 centimeter hygrogyrum for every 105 meter increase of altitude near the Earth's surface. For example, Bandung is 735 meter above the sea. What is the air pressure in Bandung? So air pressure at the sea is 76 centimeter hygrogyrum. So the pressure in Bandung equal to pressure at the sea minus the height over 105. Let's see, 76 minus 735 over 105. So it's about 69 centimeter hygrogyrum. Okay guys, that's all for today. I hope you enjoyed the video. I hope you learned something from this, and do not forget to write it down on your notebook. See you next time guys. Bye bye.